Hello, my name's Mike Taulty and I work at Microsoft in the UK. And this is one of a number of videos around a technology called Prism, sometimes known as the Composite Application Guidance. This comes from the Microsoft Patterns and Practices team and largely targets building Silverlight and WPF applications. But you can use some of the techniques and the pieces delivered outside of those spaces. So you kind of get two things with Prism. You get some documentation and you get some libraries in the form of source code that you can build up for WPF or Silverlight. And as I say, you don't have to use these inside of those kinds of applications, but some of the technologies in Prism are specific for UI work with these two technologies. Prism has a friend called Unity, which is another framework, and we'll talk about that as well in these videos. And in terms of finding these things, if you want to find Prism and so on, if you just pop to a search engine, type in Prism and Codeplex and you'll find Prism. If you want to find Unity, type in Unity and Codeplex and you'll find Unity. If you want to find these videos, you can go to channel9msdn.com/niners/mtaulty, that's me, and I'll put these videos on this site here. If you want to find me, you can go to mtaulty.com, that's my blog, and you'll find it there. If you want to find me on Twitter, you can go to twitter.com/mtaulty and you can find me on there as well. And if you want to find me on email, I'm just mtaulty@microsoft.com. Now, in this video, video 4, what I want to do is take the code that we worked on in video 3, and at the end of that video we had 4 kind of cooperating modules. We had a main module which relies on services from 3 other modules. I think a calculator module, an input-output module, and also a module that knows how to do calculator command parsing. And where we'd got ourselves to was that by using a combination of Unity and the modularity framework in Prism, we had a little console application that was pretty independent in that we just relied on the modularity framework in Prism to populate a module catalog and then go around the modules that were registered in that catalog and their dependencies, initializing them, and that initialization process registered types with the Unity container, and finally for us actually run our code. So we got to the point where we had 4 modules that know very little about each other, but they're working together by registering implementations of interface-based services and then using them, and they know that they can use them because their dependencies are marked, so they know that if module A relies on module B, then module B will already be loaded by the time module A wants the services from module B. And that's kind of where we'd got with video 3. What I want to do in this video here, video 4, is kind of move from there, and really we're just doing a sort of short springboard here, where probably in video 5 we'll move across into a Silverlight project, which is where we've been wanting to get all along, because we're starting to get to the point where we're running out of some of the services that we can do in a UI neutral manner. Some of the next services I want to look at in Prism are really more UI specific, and we'll see that start to creep in this video. So I want to use this as a short springboard that takes us next time in video 5 into a Silverlight project. But here what I want to do is, if we look at where we were in the previous project, we'd written quite a lot of code in order to get our module manager up and running. We'd had to deal in terms of a service locator for Unity, we'd had to create a Unity container, we'd had to deal with iModule, I think it's called initializer or initialization, we had to deal with iModule catalog, we had to deal with iModule manager. All this stuff kind of was thrown at us. We had to program explicitly against it just because we brought in the modularity framework from Prism. Well, here I just want to take a look at a class called a bootstrapper, and the name is pretty descriptive, and how we could use that to take away much of the pain that we caused ourselves in the previous video and get rid of having to do all this stuff manually and start using a bootstrapper to do it automatically. So let's go back to our project in Visual Studio, remind ourselves where we're up to, and we'll carry on. Okay, so just a quick recap. Last time we saw the solution, if I just collapse this all down for you, we had a bunch of modules. We had a calculator command parsing module. I'm just going to remove the breakpoints whilst we tour around this stuff, which initializes itself by registering an input parser service, which is of type input parser service. This is the interface, this is the implementation. That was one module. We had a calculator module, which initializes itself by registering both a calculator as an I calculator and our calculator read evaluate printline loop as an I calculator REPL loop. That was that guy. We had a input output module, which initialized itself by registering an input service and two output services. One is the console and one is a message box. And then finally we had a main module, which is dependent on the other three modules, because in that main module we initialize by grabbing hold of an I calculator REPL loop, so we depend on that having been registered by this point, and then we run that loop. And if we go and take a look at how that loop actually runs back in our calculator library, it is itself dependent upon I calculator, I input service, I input parser service, and also a list of I output services. So if you've been following this along, you'll know how this goes and you'll be familiar with this sort of stuff. Back in our actual application code up here, we had no dependencies left on anything really that we wrote, not static dependencies anyway, and we had a simple program which created a Unity container, registered an I service locator, registered this thing called a module initializer for the modularity bits of Prism, a logger facade again for the modularity bits of Prism. It used a configuration module catalog, which is just one of the module catalogs available that knows how to read a configuration file, and it registered a module manager. Finally, we walk up to the container, we resolve that module manager and tell it to run. The configuration for all this, of course, lives in the config file. The config file says we have a module which is our main module. It depends on the calculator, parsing and input modules, and here's how to find all of that implementation goo that we don't really have to worry about in our program back here. Okay, so that's all a little bit painful just to kind of get us down to this bit here, and some of this is pretty boilerplate. If you were always using Unity, you would always be doing a bunch of this stuff, and so rather than having to do this manually like this, there is a class in the framework to help you, and the idea of that is it bootstraps the whole process for you. So let's go ahead and use that class, and what we want to do here is bring in a new class. The idea is that you derive from the bootstrapper class given to you, and the idea as well is that this bootstrapper class is specific to the IOC, the inversion of control container that you're using. So if you are using the Unity container, you would use the Unity bootstrapping class. If you're using another container, you'd need to write your own bootstrapping class rather than just derive. But because we're using Unity, we can use this. So let's write my bootstrapper, or let's call it calculator bootstrapper, because it's pretty specific. And let's derive that from Unity bootstrapper. Okay, and what we want to do is override a couple of methods on this thing. If we take a look at Unity bootstrapper, let's just go to the definition of this. You'll spot that it's abstract, and you'll spot that there's one method on here that we have to override called create shell. Now this is the point where we start to get specific into UI framework stuff. All the stuff we've used so far, we didn't really make any mention of UI. But this thing here, create shell, is supposed to return a dependency object, which you'll be pretty familiar with if you've used Silverlight or WPF. So let's go back to our code over here, and we're going to have to override, let's just go and implement this over here, create shell. Now actually in my application I don't have a shell right now, so I'm cheating a little bit in that we'll return null. I don't have a dependency object to return. However, I do need to define dependency objects, so I'll need a reference. So I'm going to bring in a weird reference for console application. Let's bring in Windows base, and that should hopefully provide a definition of this thing so that my code will at least compile and work, even though I'm not actually going to do any WPF or Silverlight work. Clearly in a console application I won't be doing Silverlight work. Okay, great. So we've got that create shell, but there's one other thing that I want to override on the bootstrapper, and that is how it goes ahead, and you'll notice there's lots of things I could override, but I want to override its get module catalog. So how am I going to go about populating a module catalog? Well, I'm going to return a new configuration module catalog, because that's how we're loading our module catalog from config. With that in place, we can get rid of all of this code, create a calculator bootstrapper, and then tell that bootstrapper to run. Okay, so let's build. Let me just make sure quickly that all my libraries are in place. I'll just snip the video and make sure all my dependent libraries are in the right bin folder. Okay, so let's press F10. One of the joys, of course, of using Prism is that we do get the source code for it, so let's just step into this bootstrapper.run method. So this is obviously not my source code now, I'm off into the Prism framework. Let's step into this run method. You can see that this is using default configuration, so we're just going to accept a whole bunch of defaults. It comes along and gives me a logger, so it already has one, so it gives me that. It does some logging. It creates a container. Let's step into that. You can see it creating a new Unity container, so that's simple enough. Comes along, logs, adds an extension to that container for itself. Won't worry about that too much right now. Then it goes into configure container. Let's wander into there. You can see it registering that facade for the logger. And now you can see it calling me in order to get my module catalog, and there I am returning a new configuration module catalog. Registers that. And then it comes along and registers a whole bunch of things that belong in Prism. We know about iService Locator, so there it is registering that. We know about iModule Initializer and iModule Manager. We've yet to meet the next 4 or 5 things that come here, so I'm going to skip them right now, but these are more parts of Prism that we'll come to as we go along. Region adapters, region managers, event aggregators, region views, etc., etc., etc. So we're just going to whiz through that stuff, but you can see what it's doing is registering types in the Unity container, some of which we already know about, some of which we don't. Okay, let's step along. It does some more logging, it does some stuff to do with its regions and so on that we don't know about at this point, registers some exception stuff, does some more logging, and then it calls create shell, which is my function where I return nothing. This will become much more significant when we get into a Silverlight application, but right now I can get away with this. Then it initializes the modules, and we already know pretty much about module initialization. And if you remember, one of my modules actually comes along and at initialization time actually starts to run and doesn't return, so that's perhaps not great, but we are now at the point, you can see the logging stuff has come through, we are at the point where my code is now running and everything's working the way it was before. I don't think we should have really done that in initialization because we've kind of broken the bootstrapper, but if we go back and take a look at what we've reduced our code down to, we've reduced it down to this with a little bit of override, and then of course the configuration file that sits behind it. So our code is getting nicer still by using the bootstrapper rather than manually doing that work that we were doing before. Now we've really reached the extent to which we can play with some of this stuff in a simple console application, because really the idea here is that we create a bootstrapper that returns a module catalog. Now we're doing that correctly, and when we run that bootstrapper, one of the things that it will do is go through and make sure all of our modules are sorted out. But we also have this override here, create shell, which we're kind of ignoring. And the idea of this in a Silverlight or WPF application is that create shell, as the name would imply, creates the top level window, if you like, the shell for your application. And because at that point when you create that shell, various services will have been registered from your module catalog, that's kind of the point where the application starts to execute. Now in our case we're kind of cheating because we don't create a shell and we rely on one of our modules, specifically the main module down here, never returning from its initialize function, which is a little bit against the spirit of the framework. So that's just because we're coming from a console application, we're not coming from a Silverlight application. What we'll do in the next video is put all this into a Silverlight application and start to look at just the basics of having a real use of the bootstrapper and getting an application up and running.